In our linear unit, we looked at many tile patterns. We looked at the tile patterns to write the equation describing the pattern. The way we did this is we found the start value B, the start value meaning how many tiles were in figure 0, and then the rate of change M, meaning how many tiles were added to the pattern each time the figure number increased by 1. So we found the start value, rate of change, and then we wrote the equation in the form y equals mx plus b. For example, for this first tile pattern, we would have identified that the start value, how many tiles were in figure 0, was 1. And then we would look to see how many tiles were being added each time the figure number increased by 1. So to go from figure 0 to figure 1, we added 2. To go from figure 1 to figure 2, we're adding 2. Adding these 2 to go from figure 2 to figure 3. That tells me my rate of change, how many tiles are being added each time the figure number increases by 1, is 2. We're adding 2. That means in my linear unit, I would have written the equation to describe this tile pattern as y equals mx, 2x plus b, where b is 1. Y equals 2x plus 1. This means that, for example, figure 1 has 2 times 1 plus 1, which is 2 plus 1 or 3 tiles. Figure 2 has 2 times 2 plus 1, 4 plus 1 or 5 tiles. And figure 3 has 2 times 3, which is 6, plus 1, which is 7 tiles, because my figure number is always my input. So here x is 1, x is 2, and x is 3. Now that we've moved into our function unit, the only thing that is initially changing is instead of using y for my output, I'm now using f of x. So my function rule is just like my equation, except now instead of saying y equals 2x plus 1, I say f of x equals 2x plus 1. Again, this means that using my input of the figure number, I multiply the figure number x by 2 and add 1. So again, 2 times 1 plus 1 gives me an output of 3 for figure 1. Figure 2, 2 times 2 plus 1 is 5. My output, f of x, is 5 for figure 2. There's 5 tiles. My output for figure 3 is x equals 3. 2 times 3 is 6 plus 1, giving me an output of 7 tiles for figure 3. So again, so far all that's changed is I'm using f of x for my output to show that y is a function of x, my input. When I say I can use my function rule to directly visualize the tile pattern, I'm not talking about this, showing how many are being added. So I'm going to go ahead and erase this shading. I'm talking about a different type of shading or visualizing. I'm looking to directly link 2x plus 1 to my tile pattern, as opposed to plus 2, plus 2, plus 2. So I'm looking for 2 groups of x plus 1. So for figure 1, I'm looking for 2 groups of 1 plus 1. Figure 2, 2 groups of 2 plus 1. Figure 3, 2 groups of 3 plus 1. If I went up to figure 11, I'd be looking for 2 groups of 11 tiles plus 1. So let's look at that. Where can I see 2 groups of x? Let's see. So looking at this, let's go ahead and look at figure 2. That might be a little easier. Figure 2, I'm looking for 2 groups of 2. Well, here's one group of 2. And here's another group of 2. So one group of 2, 2 groups of 2. That gives me 2x. Oh, and then I'm left with 1. So my middle tile here is my 1 tile, my plus 1. Let's see if that works here. I'm looking for 2 groups of 3. Here's one group of 3. Here's a second group of 3. And then I still have that plus 1. So this looks like I'm visualizing it correctly because I found 2 groups of 2 plus that center tile. 2 groups of 3 plus that central tile. Let's look here. Center tile. And then 2 groups of 1. Here's a group of 1. And another group of 1. That tells me I have each figure consisting of 1 tile plus 2 groups, my 2x, 2 groups of x tiles. If I were visualizing figure 11 like I talked about, I would have 11, a group of 11, the center tile, and then another group of 11. There'd be 11 tiles over here. I didn't draw 11, I just wrote the number 11. So 2 groups of 11 plus 1. If I were describing what figure 33 would look like, I would have 33 tiles there. I'd have 33 tiles down below, And I always have this +1, that center tile that is in every figure number. Figure 0 just has my 1 center tile, and then there's 2 groups of 0, which I guess are invisible or don't exist. Let's go ahead and use our old way of finding the function rule and then try to relate it to the tile pattern visually. Maybe you can just directly look at this and identify some groups of X, some groups of 1, some groups of 2, some groups of 3, and that's great. But if you don't initially see that, you can use what we learned in our linear unit to write the equation first. What that means is we're looking for the start value and the rate of change. The start value is 4. Figure 0 has 4 tiles. And then we're adding 1, 2, 3. 1, 2, 3. 1, 2, 3. So our rate of change, meaning how many tiles we're adding as the figure number increases, is 3. That means in my linear unit, my equation would have been y equals mx 3x plus 4. Function unit, we're using f of x to indicate the output y, the number of tiles. F of x equals 3x plus 4. What is happening? 3x plus 4. And notice in all of my tile patterns, x is the figure number. Oh my, what is happening with my writing? X is my figure number, and f of x is my number of tiles. Wow, that looks terrible. Okay, I'm going to erase this because this is not how I want to visualize this tile pattern. I want to look for 3 groups of X. I'm looking for 3 groups of X tiles, meaning 3 groups of 1, 3 groups of 2, 3 groups of 3, plus 4 tiles. Maybe you can see that directly. Maybe you want to start with seeing, oh, there's always 4 right here, 4 right here. Those 4 are always, no matter the figure number, there are 4 tiles in the middle. And then I'm looking for 3 groups of X. So let's see, here's 1 group of 2, 2 groups, 2 groups of 2. Let's look for a 3rd group of 2. Does that work for every single figure? So we have 1 group of 3, 2 groups of 3, 3 groups of 3. Oh, and it works for figure 1 as well. 1, 2, 3. 3 groups of 1. So that means I have 4 tiles in the center, that block of 4, plus 3 groups of X tiles. So 3 groups of 1, 3 groups of 2, 1, 2, 3, and 3 groups of 3. If I were going to describe what figure 17 looks like, it would have that 4 in the middle, and then it would have a group of 17, 1 group of 17, 2 groups of 17, 3 groups of 17 tiles. For our last tile pattern, let's go ahead and try to directly find the function rule by visually looking at the tile pattern rather than identifying start value and rate of change and working backwards. So here I am looking for some groups of 1, 2, and 3. And notice I'm not given figure 0, so I would need to work backwards if I were using my linear understanding. So I'm looking for some number of groups of 1, the same number of groups of 2, and some groups of 3. So let's see. Here's a group of 3. Shade it. 1, 2, 3. Another group of 3. That's 2 groups of 3. 3 groups of 3. Need another color here. 4 groups of 3. So it's looking like I have 4 groups of X. There's 4 groups of 3 plus those 3 in the middle. So each figure consists of 3 tiles plus 1, 2, 3, 4 groups of X. Let's see if that works for all of them. So there's always 3 in the middle, 3 in the middle. And then for this one I have, 1 group of 2, 2 groups of 2, 3 groups of 2, and 4 groups of 2. So I have 1, 2, 3, 4 groups of 2 plus those 3 in the middle. Figure 1, does it work? 1, 2, 3, and 4. What color is that? 4, so we have 4 groups of 1 plus 3, 4 groups of 2 plus 3, 4 groups of 3 plus 3. That gives me my function rule. F of x equals 4x plus 3. If I were describing figure 20, I would have those 3 in the middle, 1, 2, 3, and then I would have a long arm this way that had, did I say 20? 20 there. There's 1 group of 20, 2 groups of 20, 3 groups of 20, and then 4 groups, back to that weird color, but at least it shows up, and 4 groups of 20. So I would have 4x, 4 groups of 20 plus 3 in the middle. Now when you're directly finding the function rule, as I just did from the visual pattern, rather than b and m and plugging it into y equals mx plus b, it's a really good idea to make sure that your function rule correctly predicts the output, or the number of tiles. So let's make sure that it does. For figure 1, x is 1, so there should be 4 times 1, which is 4, plus 3 tiles. That is 7. So are there 7? 1, 2, 3, 4, 5, 6, 7. Yep. Figure 2 should have 4 times 2, which is 8 plus 3, or 11 tiles. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like it's working. Figure 3 should have 4 times 3, 12 plus 3, which is 15. 3, 6, 9, 12. Yep, 15 tiles. So in short, when you are trying to visually connect the tile pattern to the function rule, you can either try to do that directly, looking for groups of the figure number, groups of 3, groups of 2, groups of 1, or you can use what we learned in our linear unit, find the start value, find the rate of change, and then knowing how many groups of x there should be, look for those groups of x. So look for 2 groups of x, look for 3 groups of x. In this case, look for 4 groups of x.